GCSE Physics, Energy and Required Practicals. Required Practical 1, Specific Heat Capacity. The core concept. Describing the experimental method to determine the specific heat capacity of a material, usually an aluminium block, and minimizing energy losses. Example question. Describe a method a student could use to determine the specific heat capacity of an aluminium block. Include the equipment needed and how to minimize errors. Student lesson breakdown. Equipment setup. Measure the mass of the aluminium block using a balance. Place an immersion heater and a thermometer into the two holes in the block. Connect the immersion heater in series with an ammeter and power supply, and a voltmeter in parallel across the heater, or use a joule meter. Method. Wrap the block in insulation like bubble wrap to reduce heat loss to the surroundings. Read the initial temperature of the block. Turn on the power supply and start a stopwatch. Take readings of the voltage and current to calculate electrical energy and record the temperature every minute for 10 minutes. Analysis and accuracy. Calculate the temperature change. Use the equation. Change in thermal energy equals mass times specific heat capacity. Rearrange to find the specific heat capacity. Specific heat capacity equals change in thermal energy, mass times by temperature change. Energy transfers. Bungee jump or roller coaster. The core concept. Describing how energy shifts between different stores during a dynamic event, emphasizing the conservation of energy. Example question. A bungee jumper leaps from a high platform. Describe the energy transfers taking place from the moment they jump until they come to a complete stop at the bottom of the court. Before the jump, the jumper has a maximum store of gravitational potential energy, GPE, on the platform. During the fall, cord slack, as the jumper falls, GPE is transferred mechanically into the kinetic energy KE store. The speed increases. As the cord stretches, the bungee cord begins to stretch. KE and remaining GPE are transferred mechanically into an elastic potential energy store of the cord. At the lowest point, the jumper temporarily comes to a stop. The kinetic energy store is 0 and the elastic potential energy store of the cord is at its maximum. System losses. Throughout the jump, some energy is dissipated into the thermal energy store of the surroundings due to an air resistance and the stretching of the cord.